Welcome to The Explainer, where we break down big ideas. Today, we're diving into something that could completely flip the script on how we build reliable AI. So, why do they fail? I mean, we've got these incredible models, right? They can write poetry, they can code, but ask them to do a long, complex task where every single step has to be perfect? That's where things fall apart. Think about it. Even a tiny, tiny 1% error rate. Well, after 100 steps, your chances of success are basically zero. It's a huge problem. And there's a name for this phenomenon. It's called the reliability cliff. And it's exactly what it sounds like. A recent study, and I love this name, called The Illusion of Thinking really drove this home. They gave these super smart AIs puzzles that get harder and harder. At first, no problem. But then, bam, they hit a wall. Performance doesn't just get a little worse, it completely collapses. It falls off a cliff. And get this, the weirdest part is that giving them more thinking time actually made them less reliable. So that puts us in a really tricky spot, right? If our main strategy is just build a bigger, smarter model, but that just leads us to the same cliff faster, are we just stuck? I mean, how are we ever going to trust AI with the really important stuff like manufacturing or logistics, things that need millions of perfect steps, if they can't even get through a few hundred without failing? Well, that's where this groundbreaking question from researchers at Cognizant AI Lab and UT Austin comes in. They basically said, hold on a second. What if we're all looking at this the wrong way? What if the problem isn't the AI's thinking ability, but the way we're structuring the work we give it? Instead of building one giant, perfect brain, what if we changed the structure of the problem? And this really lays out the two different paths we can take. Path one, the one we've been on, is all about bigger intelligence. Just build one massive, super smart model and hope for the best. But we know where that leads, the reliability cliff. Path two is totally different. It's about smarter structure. It's not about the size of the brain, it's about the design of the system. It's designed from the ground up to nail millions of steps flawlessly. And this new approach, this smarter structure idea, has a name. It's a system called Maker that stands for Massively Decomposed Agentic Processes, which is a mouthful, I know, but trust me, it's a game changer for AI reliability. Okay, so here's the secret sauce. Maker doesn't try to get one super genius AI to solve a giant problem. No, instead, it takes that problem and just smashes it. It shatters it into millions of tiny, tiny, manageable pieces. And then each of those little pieces gets handed off to what they call a micro-agent, a little AI that has one job and one job only. Okay, so how on earth does breaking a problem into a million pieces lead to perfect results? It sounds kind of counterintuitive, right? Well, it's not just about breaking it down. It's about a really clever system that has three key ingredients. All right, let's walk through it. First, you've got that maximal decomposition, smashing the problem into the smallest possible steps. Step two is voting for consensus. This is awesome. For every tiny step, you don't just have one agent working on it, you have several all at the same time. And the system only accepts an answer when enough of them agree, when one answer gets a clear majority. It's like a tiny election for every single move. And third, there's red flagging. This is basically a built-in nonsense detector. If an agent gives a weird answer, maybe it's way too long or just gibberish, the system sees that red flag and just tosses it out before it can even mess up the vote. And that combination is where the magic happens. You see, these three simple rules create this incredibly robust system where any potential error gets caught and squashed instantly at the micro level. It never has a chance to grow or affect the next step. So you get these tiny local agreements that when you stack them up a million times, build into this massive global long-term reliability. Okay, this all sounds great on paper, right? But does it actually work? Well, to find out, the team decided to throw an absolutely brutal challenge at Maker, a real gauntlet, something designed to be pretty much impossible for any single AI we have today. And their weapon of choice? The classic Towers of Hanoi puzzle. You've probably seen it. It's the perfect test because it scales exponentially. A few disks, easy, but 20 disks? You're looking at a perfect sequence of over 1 million moves, where every single move depends on the one before it. Yeah, you heard that right. Over 1 million consecutive, dependent steps. Every single one has to be perfect. If you make just one mistake anywhere in that chain, the whole thing is ruined. It's the ultimate stress test for reliability. So, the big question, how did Maker do? Just keep in mind, Our best single AIs tap out on these kinds of problems after maybe a few hundred steps. This is a million-step marathon. It's not even in the same league. The result? Zero. Zero errors. Maker absolutely nailed it. It solved the entire million-step problem without a single mistake. Flawless execution. And you're looking at it right here. This is the system in action. Each of those little dots is one of those million-plus micro-agents doing its job, all of them working together in perfect harmony. I mean, this is basically the first time we've ever seen visual proof that an AI system can achieve this kind of insane, long-term reliability. But here's what might be the craziest part of the whole thing. You'd think for a task this complex, you need the most powerful, expensive models for those little microagents, right? Nope. The team found that smaller, dumber, non-reasoning models were actually the most cost-effective choice. It just goes to show, if you get the structure right, you don't have to win the model size race. Smarter design beats bigger models. Okay, let's zoom out. Why does this matter so much? Because this isn't just about solving a puzzle. This is a whole new blueprint for how we can build AI that is not only powerful, but that we can actually finally trust. Yeah, the implications are just massive. For reliability, we now have a clear path to building AI that can handle really complex, real-world stuff, manufacturing, medicine, you name it. For transparency, because each little agent has such a simple job, the whole system is way easier to understand and check. That also makes it safer. Using smaller models with very specific jobs reduces a lot of the risks we worry about with single giant super AIs. And of course, it's way more efficient. It proves we can scale intelligence through smart design, not just by building bigger and bigger models. And for anyone out there in the tech world, this whole idea probably sounds pretty familiar. It's almost a perfect parallel to the huge shift from monolithic software to microservices. We learned a long time ago that building big, resilient systems is easier when you use small, independent, cooperating parts. It's a proven strategy, and now we're seeing it applied to AI. And this quote from the researchers themselves just sums it all up perfectly. By smashing large problems into minimal cooperating agents, AI can scale far beyond the limits of single models. It's not about one powerful agent. It's about the incredible reliability that emerges when millions of simple agents work together. So that leaves us with this really provocative question to chew on. For so long, the quest for AI has felt like this race to build one single giant brain, a sort of digital god. But what if that was never the right path? What if the future of truly powerful, safe, and reliable AI isn't one giant brain at all, but a million tiny ones, all working together in perfect concert?